Oh, because I used it double, yeah.
So question 2 is more difficult than I had anticipated.
Yeah, them 2, yeah. So we got 3. High five, man. I don't know if this thing will give me 1 less than you on everything, but it's cool. It's cool.
Well, I also wrote a whole page more than you wrote, and I only got 1 extra point.
That's not the point. The point is, are we recording right now?
Yeah.
We are recording?
Mm-hmm. Yeah.
I'm sorry.
So yeah, I'm going to wait to publish these until after Eliason's taken his.
Oh, he hasn't taken this?
He hasn't taken it yet. Yeah. But yeah. So this is the question that was asked. I think what I had in mind, if I could go back in time and rewrite the question, I would have liked to have asked you this one instead. Almost looks the same.
No, it doesn't. Not at all, Mr. Emo. Because I can answer B sub n.
Yeah.
But that sign of one sub n times n makes it a crazy, crazy freaking oscillating, like, and I'm like, I gotta find something that terminates, that both have the same,
Yeah.
I mean, so here's the question. If I would have written down what I would have done if I knew how to do that, would you have given me more than 2 points? Like if I was like, oh, I'm gonna find a series or function, in this case, we're gonna turn into a function, that that is less than and greater than the given, and that they both convert to the same point. I would start with the start of whatever, and then work from there. You see what I'm saying? If I would have written that out, yeah, written it out. Versus because, I mean, that's crazy.
Yeah. Well, with this one, what can I say?
I did cosine, negative cosine plus 1, negative cosine plus 5.
All right, I'll say something about this, right?
Excuse me, sorry.
I'll say one thing about this. Notice that this is the same thing as that.
Okay.
And as n gets huge, this goes to 0, and this goes to 0. And in fact, they both go to 0 at the same rate, so to speak.
Okay.
And so I think if you had if you saw it from this point of view, it might maybe have reminded you of something from differential calculus.
Yeah, calculus 1.
We took some time. In fact, we took a.
That was the first squeeze theorem thing.
Yeah, I think that was actually a pretty substantial argument. We took probably at least an hour, I think, going over this argument.
Oh, okay. To prove that sine. Okay.
So, see that?
You're right.
We went through great pains to show that
Great pain.
that this, as x is close to 0, notice it's an indeterminate form. Sine of 0 is 0. 0 is 0. So this is an indeterminate form. So we had to use some a sort of squeeze theorem to show that this was equal to 1. And for that same reason, this one is also going to be 1. And in order to do that, I would have to basically rehash the same argument from here, right? That, or just kind of state this as being true and then kind of state, but then I'm not using the squeeze theorem, right?
Right.
But yeah, that would be an interesting way to do it too. So yeah, so this is, so the argument here is literally the same argument that we used to show this. Okay. But yeah, this one's quite a bit. I think this one is really what I was expecting you to do, right? Something like that. Like, how would you have handled this one? What's the first thing you would have done? I'm pretty sure you would have got the first step right because I saw it on your papers. You were trying to use the technique here.
Sine, yeah.
Yeah. So naturally enough, you would have said
Sine between -1 and 1.
Yeah.
We both got that. That's.
Yep.
And from that point, that's when I just started making stuff up.
Yeah, I can tell.
Yeah.
Yeah, see right here, you know? And then to kind of make it look like this, I need a 1 over n, right?
Right.
So this one's a little bit weird. To really do this properly, I was curious to see how you do it, you know? Like what you want to do is you want to multiply through by 1 over n,
Multiply, yeah.
right?
Yeah, but
you know, this is a subtlety that I might, if I did ask the question this way, there's a subtlety that you might not have caught, and then I would just kind of explain it after the test.
So
It says-
divide-
oh wait, no, actually n is positive. N is positive. Okay, never mind. Yeah, you'd be fine. No subtlety.
what? Yeah, what do you say?
No worry. Okay, so you're multiplying, but n is positive because
Okay.
n is we're looking at a sequence. As n gets huge, that's a positive number. I was worried about multiplying through by a negative number, right? And then in the middle, I got to multiply that by.
Wait, is that's supposed to be a -1?
Oh yeah.
Okay.
Yeah.
I was gonna ask that. I was like, man,
Yeah.
I don't want to look more dumber than I.
Yeah. So since as a sequence, not as a series, but just as a sequence, this is getting closer and closer to 0.
Right.
This over here is also getting closer and closer to 0. And this is limiting to something that's in between 0 and 0.
Which is 0.
Must be 0.
Yeah, can you write that one out?
Yeah, okay. Here it goes.
Oh, seriously, man, that's the one
Because
you
like
wanted to ask?
mine looks like that,
Seriously, this is the one you wanted to ask.
Yeah.
but mine looks exactly
For
like
25
that.
points on your exam. Now, I think you picked the right one. I think that's literally the one you wanted.
Yeah. Yeah, so for this one,
Mine looks exactly like that though.
Yeah, that's what mine, but I was like, it can't be because.
so as you know, if you have an angle, in this case, because it's a sine, I'm regarding 1 over n as if it was an angle.
Right.
And if n is large, it would be a very small positive angle.
Okay, yeah.
Right. So let's just say the angle is right here. This angle is 1 over n. 1 over n radians.
So 1/3.
Yeah, like 1/3. N equals 3. And you can see how this would be, we would call this the sine of 1 over n.
Right.
I would call the arc length just 1 over n, since it's a circle with a radius
It's just
1.
one. Yeah.
And I would call, and if I have a tangent line right here, like this, and extend this radius, then this right here would be the,
Tangent.
yeah, exactly, so that's the tangent of 1 over n. This would be the sine of 1 over n. And this arc right here, in between the two, is just 1 over n. So again, the radians on the unit circle is literally the arc length.
Right.
And if I write that down, I don't really need this half of the circle. If I write that down, I can relate these three distances with an inequality by saying that the sine of 1 over n is less than 1 over n, which is also less than the tangent of 1 over n.
Okay.
But so,
All divided by n.
but then the question is,
Mm-hmm.
don't they both have to be on the opposite side of sine 1 over n, since sine 1 over n is the original?
Yeah, I'm not going for this one. I want the sine of 1 over n to be here.
Right.
So the way I'm going to do that, I'm going to be constructing this expression right here.
So you're saying sine squared 1 over n is less than 1 sine 1 over n, which is less than sine tangent 1 over n?
A little bit different. I'm not going to do that. What I'm going to do is I'm going to say, what I do is I'm going to flip all these fractions. Notice this is sine over cosine.
Right.
This is sine over 1.
Right.
I want to flip them. But I can only do that
If
if they're all positive. If some are positive and some are negative, like, who knows what's going to happen.
so that's when okay, I'm sorry to keep getting in your way, but that has to be, but that was given to us in the, oh no, I guess it wasn't given to us in the original as far as like the summation
Mhm.
of n0 to infinity. Okay, cool.
But they'll always be positive, right? As n goes to infinity.
Yeah. Yeah, a sign of a positive number. A sign of any number in the first quadrant is going to be positive. So I can safely say that these are all positive. So when I take the reciprocal of each one, the small number is going to become the biggest one is going to become the smallest.
Right.
So what I end up with is this, is 1 over the sign of 1 over n is less than n over 1, which is less, oh, wait, hold on. I just said it, but I didn't write it. The smallest one, after you take reciprocal, is now the biggest. So I'm switching these inequalities. And tangent, I'm going to rewrite, the reciprocal of tangent, I'm going to write it as cosine over sine.
Okay, I'm sorry to keep going.
Mm-hmm.
So now that 1 over sine becomes cosecant? No, secant. No. Yeah, cosecant. And that becomes cotangent.
Yep,
Okay.
but I'm not going to bother with that.
Well, I was just gonna then relate it to the actual graph.
True.
We're no longer talking about these. We're now talking about
Mhm.
from the y-axis out to the intercepts, right?
Oh, yeah. Oh, interesting idea. There might be I might be able to bypass this step if I look at the picture just the right way. And see, find the cosecant on the graph, find the cotangent on the graph.
Right.
I didn't think of that. But yeah, at this point, what I had in mind is I have an n. That's this n. What I'm going to do is I'm going to multiply through the inequality by this, the sine of 1 over n. I'm going to multiply all three of these by the same thing, the sine of 1 over n. So over here on the left, which is actually the largest of these three expressions,
Right.
you get 1. In the middle, I have n times the sine of 1 over n. And on the right, signs cancel, and I'm left with the cosine of 1 over n. So the expression that I'm interested in, right here, is trapped between 1 and the cosine of 1 over n.
As n goes to infinity.
1.
And as n gets huge, the cosine of a really tiny number was going to be really close to 1. And of course, constant converges to itself. So if this is trapped somewhere between 1 and 1,
Does a constant converge to itself? Or is it just itself?
yeah, that's just semantics.
Okay, I'm sorry. Can we draw it now? I'm sorry. Go secant.
Oh yeah, oh yeah. So for the purposes of review, the cosecant, if you were to consider, all right, a different tangent line, namely this one right here, which goes off the board somewhere, and if you were to extend this line until it hits that tangent line, yeah, right there, and it intersects right at that push pin, right?
Right.
And so the cosecant would be the length of this
Right.
right here. And the cotangent would be the distance right here. Right?
Right.
And n would be somewhere in between those two numbers.
That's a big range though.
Yeah. Yeah. It's not totally obvious to me just looking at the picture that that's the case, but that's what we've shown. So anyway, that's the argument. And it would be a distant memory from differential calculus. This is also the reason why we know. This is also the reason why we know that the derivative of sine is cosine. Every time you use that fact, you're using this. And that's the exam. We'll think of it as a learning experience.